I talked about the area of a trapezoid. Trapezoid is a figure, the four-sided figure, where just two sides are parallel. Say those two. No other symmetry or anything. The two sides that are parallel are called the bases. You have base 1, base 2. And we want to find the area. We want to find the area. And I'm going to drop my perpendicular, and I'm going to call that H. Well, B1 is all of this. And for the record, I'm going to draw another perpendicular. So basically, now, I don't want you to think that there's any symmetry going on. There's not. Suppose that's the trapezoid. Trapezoid A, B, C, and D. Okay. Now, what is the area of this trapezoid? Suppose I call this area, that length X, and this length Y. So what's left in the middle, the whole length used to be B1, but I just took away X and Y. That's the area, that's the length of this right here. It's B1 minus X plus Y. Okay. So now we have three regions. 1, 2, and good old 3. Well, the area of region 1, it's a triangle, so it's over 2. It's the base times the height. Okay. The area of region 2 is base times height. Well, the base is B1 minus X minus Y times the height over nothing. Plus the area, so area total. This is area 1. This is area number 2. And we're going to now add on area 3, which is another triangle. It's the base times the height. It's Y times H over 2. Now, to have a common denominator, I'm going to multiply over here, top and bottom, by 2. So everything is over 2. We have XH plus 2H times B1, 2H B1 minus 2XH minus 2HY minus 2HY plus HY plus HY. Combine like terms, see what we get. Plus YH or HY. Well, we clearly have 2 on the bottom. We have 2HB1 on top. And if you have XH and you take away 2 XH's, you are minus XH. And if you have HY or YH and you take away 2 of them, you are minus 1 HX. Coming to the top, please, I can factor, it's all over 2, I can factor out an H. And, yeah, interesting. I'm going to change what I have in the middle here. I'm going to change what I have in the middle there, which means I'm going to get rid of the whole bottom. Sorry about that. when it comes to this middle area, what I said was right, but this is actually B2. It's B2 times H. B2 times H. Okay, and in order to have a common denominator, I'm going to do like I said. Okay, so now everything is over 2. And each term has an H in it. Well, I'm going to factor out the H. Not the Y, but the H. I'm going to factor out the H. And I choose to write the 2B2 first, plus the X, remember I factored out the H, plus the Y. Plus the Y. Okay. So this is H times B2. I'm going to write it as B2 plus B2 plus X plus Y. All over 2. And then I'm going to come up to the top. Everything's over 2, and I factored out an H. B2 plus. Now, B2 is also B1 minus X minus Y. So the other B2, I'm going to write as B1 minus X minus Y. Plus X plus Y. And these X plus Y's are all going to cancel. This is going to cancel. So I'm left with is H times B2 plus B1 over 2. That is, to make this picture, let me draw the picture again. If the bottom is B1 and the top is B2, and those are the parallel sides, the area is going to be the average of the two bases times H. Exactly what I have here. You average the two parallel bases and you multiply by the height. Because the record, if you go to the middle of this, which is right there, and you go to the middle of this right there, that is the average height. That is B1 plus B2 over 2. And we're going to use that fact in some of the problems. Okay, so that's the theorem or formula to find the area of a trapezoid. The two parallel sides, you take the average of them, that is, you add them up, divide by 2, and you multiply by the altitude, the length between those two parallel sides. Do a handful of problems, then we'll be done. Suppose these two sides are parallel. One's a little bit shorter, excuse me. 12, 13, parallel, right angles. And this is 4. Let's make this 18. Well, the altitude is the line that goes from the two parallel lines at right angles. That is H. We have H. Problem is done. The area is going to be the average of the two bases times 4. The two bases add up to 30 over 2 times 4. 2 into 4, 2 times. 30 times 2 is 60. 60 square units. Because these are in some units. 12 units plus 18 units is 30 units over 2. 4 units, which became 2 units. Unit times unit, unit squared. Sometimes you don't have to be given the bases. You don't have to be given the bases. Who needs the bases? Why would we need the bases? These two sides are parallel. I tell you the altitude is 6. And I draw this line, and I say it's the midpoint by saying that both of those sides were bisected. This side was bisected at this point, and this side was bisected at this point. But I tell you that's 12. That length is 12. That is the average of the two bases. This is base 2. Here's base 1. You want to reverse those numbers? You can call this one base 2 and this one base 1. That won't matter, but what is important is that the average is 12. And the area is B1 plus B2 over 2 times H. Well, I know what this is. That is, I know what that is. It's 12 times 6, 72. So I don't even know where B1 and B2 are, but I know their average. And this has to be both midpoints. The length of this line is of no concern unless it cut this line into 2 equal pieces and this line into 2 equal pieces. And to think that these 4 pieces are the same length, think again. Because in theory, remember, straight up and down is 6. This is just a little bit more than 6. But this line is way, way longer than 6. Nonetheless, the midpoints will be parallel to these two sides because they were given to be parallel, and it'd be the dead center. That is, it'll be the average. It'll be the average. So that's good to know. Now, you have some trapezoids that have symmetry. You have some trapezoids that have symmetry. And with the symmetry, you can figure out the height. Suppose this is 21 centimeters and this side is 31 centimeters. And so these are the parallel sides. And you were told that these two are equal to one another. What does that tell us? That tells us when we go down at a right angle that these two are the same. More importantly, those two are the same. We have similar triangles. We have similar triangles. We have similar triangles. Okay, now I know that that distance is 21, but this is 31. It's 10 more. Oh, you mean 5 are here and 5 are here? And I did leave out one thing. This is given to be 13. So everything that's in black was given. Now, I know that the area is, you add up the two bases, divide by 2, and then multiply by h. Well, I don't know h yet. This side right here, that's h. But you know what? I can find h. I have a right triangle. This is h. This is 5. This is 13. H is 12. You really should remember that 5 squared plus 12 squared equals 13 squared. If you don't worry. You can call it X or Y or Z or C for Charlie, whatever you like. X squared is 13 squared minus 5 squared. You can add these two numbers, get 18. You can subtract the two numbers, get 8. And when you multiply them, you get 80 and 64. You get 144. So, X is 12. 12. 2 goes into 12 6 times. And the units are 21 and 31 centimeters. That adds up to 52 centimeters. And when you multiply that by 6 centimeters, you get, I guess, 312. 6 times 50 is 300. 6 times 2 is 12. 312 times centimeter times centimeter is 312 square centimeters. So if you have this symmetry, the difference between these two, which were 10, divided by 2. 5 of the 10 go here, and the other 5 of those 10 extra centimeters go there. And how do we know when we have this symmetry? If you were told the two non-parallel sides are equal in length. Okay. Suppose we don't want to know the area. Suppose the area is given, but the height's not given. And in this last problem, the height wasn't given, but we were able to find it due to symmetry. But in this problem, no symmetry. 22 and 8. There's no real symmetry. But I tell you that the area is 135. Now we know the area is B1 plus B2 over 2 times H. The area is 135. B1 plus B2 over 2 times H. Well, let me come here, please. 135 is equal to, you add those two numbers, 8 and 22, you get 30. Divided by 2, it's 15. 15 times H is 135. So you go on the side. 15 times 7, well, that's 105. Now, if you're clever, you see that you need to add 30. You need to add 2 more 15s. So maybe you try 15 times 9 and it'll work. 5 times 9 is 45. 9 times 1 is 9 plus 4 more is 13. H is 9, because 13 times 9 is 135. So sometimes you can find H, sometimes you can find B1. And let's do this problem again. Suppose I tell you that H is 9, but I don't give you B1. I don't give you B1. Okay, so let's do it all over again. Give you everything but B1. The question is, can we do it? I mean, the answer is yes. If you have one equation with one unknown, you can solve it. And, you know, I'll call it B1. Okay, B1. That must be B2. So 135 is equal to B1 plus 22 over 2 times H, which is 9. What I would do is, I would multiply both sides by 2 over 9. That way the 9 cancels and the 2's cancels. 2 over 9. And 9 times 15 is 135. That is, 9 goes into 135 15 times. So 2 times 15 is 30, and it equals B1 plus 22. What number, when you add 22 to it, gives you 30? You really should know that. 22 plus 8 is 30. So B1 is 8. It finishes this problem as well as this section.